Hi everybody, hope you are doing well. About the periodic trends. Last video, I explained the periodic table and the general characteristic of the periodic table. As I mentioned before, periodic table has vertical groups starting from group 1 to group 18. Group 18 is the noble gases, and horizontal rows or periods. Okay, so to the right we can find metals, to the left we can find non-metals. So what are the periodic trends? First, we will talk about the chemical reactivity, the trend of chemical reactivity over the periodic table. Okay, so reactivity is the ability of a certain element to react, to chemically react. Okay, so chemical reactivity is high in group 1 and in group 17. So the first group from the right is the highest reactive, and the first group after the noble gas from the left is the highest reactive. And as we go to the middle, as we move to the middle, the left, the middle, reactivity decreases, and from the right to the middle, reactivity increases. The noble gases in group 18, they are already very stable because the outermost shell is full of electrons. So it's very hard to react, to lose or gain electrons. Okay, so they are the least reactive elements in the periodic table. So the last group, group 18, the noble gases group, is the least reactive group because it's the most stable elements. So if we take within the same group, if we look within that same group, for example, in group 1, which is metal, reactivity increases going from top to bottom of the group in that direction. Reactivity increases. So the element at the bottom of group 1, for example, is the highest reactive one in that group. And at the top, it's the least reactive element in the same group. But for non-metals, the opposite. If we take 17, the halogens, as an example, so as going up for the non-metal groups, reactivity increases. So the bottom of the same group of non-metals is the least reactive element, and the top of the same group of non-metal is the highest reactive element. Going from middle to left and from middle to right, reactivity increases too. So in the middle, they are less reactive elements. As known from the periodic table, that elements within the same group have the same number of valence electrons. For example, group 1, all elements in group 1 have only one electron at the valence shell, the outermost shell. Group 2 has 2 electrons All the elements in group 2 have 2 electrons at the outermost shell. Group 3 have 3 electrons at the outermost shell. So elements within the same group have the same number of electrons at the valence shell. Okay? And the chemical behavior is based on the number of valence electrons. Valency determine the chemical behavior or the chemical properties of the element. So it is expected that within the same group, elements will have similar chemical behavior. The difference in reactivity will come from the number of shells. The number of shells. As going down in the book, the number of shells increase. For example, group 1 starts with hydrogen. Hydrogen is 1 electron, so it has only 1 shell. Then after hydrogen, below hydrogen, there is lithium. Lithium has 3 electrons, which will be distributed into 2 shells. After lithium, sodium. Sodium has 11 electrons, so they will be distributed in 3 shells. So the difference in chemical behavior here, it depends on the number of the electronic shell. The variation or the trend that can be seen in the periodic table. So the atomic radius, another trend in the periodic table. The atomic radius is the distance between the nucleus to the edge of the atom. But in fact, the edge of the atom can be measured because, as I mentioned last time, that electrons are moving in clouds, so it's very hard to know where is the edge, where is exactly the edge of the atom. So there is another way to measure the atomic radius, which is half the distance between the nuclei of 2 adjacent atoms. This is an atom and this is another atom. And if we measure the distance between the nucleus 1 and nucleus 2 and divide it by 2, we'll get the atomic radius. Anyway, this is the exact way how they measure the atomic radius, but consider it from the nucleus to the edge of the atom. Okay, so what is the trends of the periodic table? What is the trend of the periodic table, of the atomic radius in the periodic table? I will take group 1 as an example. So group 1 start with hydrogen, and the hydrogen has only 1 electron. Okay. After hydrogen, we have lithium. Lithium has 3 electrons, so they will be distributed as 2 and 1. This is the electron configuration of lithium. Below lithium, we have sodium. Sodium is 11, so it will be distributed as electron configuration is 2, 8, 1. Okay. If we draw the atomic model of hydrogen, lithium, and sodium, they are in group 1. Okay. So if we start to draw them, so for hydrogen, we will have only 1 shell. Okay. For lithium, electron configuration is 2, 1, so you will have 2 shells. Sodium 2, 8, 1. So sodium will have 3 shells, and so on. As going down in the same group, Number of shells will increase. Number of shells will increase, which means a larger radius, a larger radius. So radius within the same group will increase as going down the group. Why? Because the number of shells are increasing. Okay? If we look at two, lithium, magnesium, and calcium. Beryllium is 4, so will be its electron configuration will be 2 and 2. Magnesium is 12, so the electron configuration will be 2, 8, 2. Calcium is an atomic number of 20, so the electron configuration will be 2, 8, 8, 2. If we draw the atomic model, they are in the same group, in group 2. Okay? So beryllium have shells. Sodium will have, magnesium has 3 electron shells. While calcium has 4 electron shells. So as going down the group, electron shell increases and the atoms become very large as going down the group. This is example from group 2, and we took another example from group 1. And if we move over the periodic table in every group, we will see the same pattern, the same trend. As going down the group, the electron shells, the number of electron shells are increasing. And this increase will lead to an increase in the radius. So the trend of the radius increases as going down the group. What is the trend of the atomic radius over the same period? I will consider period number 2 as an example. Period, every element, same period, has the same number of shells. Period 2 has 2 shells, If we consider lithium in period 2, lithium is 3 electrons, so distribution is 2, 1. Let's draw 2 shells for every element, and then we will distribute the electrons. Lithium has 3 electrons, 2 and 1. Beryllium, 4 electrons, 2, and 2. Boron has 5 electrons. The distribution or electron configuration is 2 and 3. Fluorine has 9 electrons. Its electron configuration would be 2 and 7. So now we have, over the same period, we have the same number of electron shells, but the number of electrons in the outermost shell is increasing over the period. So what will be the atomic radius trend over the period? Increases in the outer shell. It means that more negative charge and more positive charge. Why? Because, as you know, the number of positive protons equal to the number of negative electrons. So as the number of electrons increases, we expect that the number of protons increases too. So more positive charge in the center in the nucleus and more negative charge in the outer shell. So more attraction force. Attraction force increases. So as the negative charge and the positive charge increase in the same atom, so the attraction force increases. As the attraction force increase, the outer shell will be attracted and shrink and come closer to the nucleus. So the size will decrease, which means same period. Why it is not working? Anyway, as moving from, oh yeah, because I didn't choose them. From the right to the left over the same period, the radius decreases. Again, why? Because there will be more electrons, more negative charge, and more positive charge in the nucleus. So the nucleus will attract the shell. There will be more attraction force between the nucleus and the electrons, which means the shell will be attracted closer to the nucleus, which means the atom will shrink. That's why the atomic radius decreases over the period from right to left. Again, the atomic radius increases over the same group from moving from top to down because the number of shells increase, so the radius increases too. While over the period, moving from right to left, the radius decreases. Why? Because the total positive charge increase and the total negative charge increase too, which means more attraction between the nucleus and the electrons. And as the attraction force increases, the nucleus attracts the shell to be closer to shrink, which shrinks the nucleus, shrinks the atom. This is the trend in the atomic radius. The atom has the nucleus with a positive charge and the electrons outside the nucleus with negative charge. As both the positive charge and the negative charge increases, attraction force increases too. Ionization energy. Trends in ionization energy. So what is ionization energy? Ionization comes from ion. So it is the energy required to convert an atom into ion, which is the energy required to remove an electron from an atom in the gaseous state. In other words, it is the energy required to form a positive ion or a cation. And as the electrons become closer to the nucleus or smaller atomic radius, the attraction force is more, and the removal of the outer shell electrons will require a higher energy. Again, consider this atom and this atom. This atom has a larger radius, and this is a smaller radius. Okay? So if we look at the outer shell is closer to the nucleus in the smaller atom, which means more attraction, which means that electrons are tied more to the nucleus. They are attracted more to the nucleus. So to take this electron out, cation, this will require a higher energy to break the attraction force, the strong attraction force. But if we look at this nucleus, this atom, which is larger, distance between the nucleus and the outer shell. So the attraction force from the nucleus to the electron in the outer shell will be decreased, will be less, okay? And to take out this electron, you will require less energy, less effort. So as the radius become larger, as the attraction force become lower, and the energy required for ionization is lower too. While if the atomic radius is smaller, electrons are closer to the positive nucleus, and then the attraction force will be higher between the nucleus and the electrons. And as the attraction force is higher, it will be harder to remove an electron, and the process will require more energy. So if we can compare the ionization energy over the same group and over the same period, we can mimic what we said in the radius, in the trend in the atomic radius. So as moving down the group from top to down, the radius increases. So the ionization energy will decrease. We will require less energy to remove electrons from the larger atom. Moving over the period from right to left, sorry, from left to right, the radius will decrease and ionization energy will increase. So it is the opposite. As the radius increases, ionization energy decreases, while if the radius decreases, so the ionization energy will increase. Okay? Ionization energy depends on which electron will be removed. So we call it ionization energy 1 if it is a removal of the first electron. The removal of the second electron is ionization energy 2. The energy required for removal of the second electron will be ionization energy 2. Okay? So hydrogen will form proton and lithium will form lithium cation and one electron which will be lost. Magnesium will form magnesium positive 2 cation and 2 electrons will be released. This is the trend in ionization energy. As the atomic radius increases down the group, ionization energy decreases over the group. So ionization energy increases to the top of the from bottom to top. And the atomic radius increases from left to right, but the ionization energy increases from right to left. Again, atomic radius is inversely proportional to the ionization energy. As the atomic radius increases, ionization energy decreases. Why? This is the trend. Why? Because uh, as the radius become larger, it means that there is less attraction force between the nucleus and the outermost shell, and it is easier to lose electrons. I1 or ionization energy 1, it is the first ionization energy or the energy required to remove the first electron. I2 or IE2 is the second ionization energy or the ionization energy required to remove the second electron. Usually, second electron will need more energy to be removed. These are examples of the ionization energies of different elements when removing one of the electrons. As you can see, electrons will require more energy. And when you need to remove an electron from a full shell, you will need a very high ionization energy. Affinity and electronegativity. What is electron affinity? Electron affinity, it is the opposite of ionization energy. Ionization energy is the energy required to lose an electron, to convert an atom to cation, while electron affinity is how easy an atom accepts an electron, how easy an atom is turned into a negative ion or anion. So as atoms are smaller, there is more attraction between the nucleus and the electron on the outermost shell, and also less electron shielding. So the atom will love to accept more electrons, the opposite of the ionization energy. So it's energy that occur when electrons is when an electron is added to the gaseous atom. If we have an X atom in the gaseous state and it accepts one electron, it will turn into a 9, and there is uh, an energy called electron affinity. The trend here is slightly irregular across the period. The electron affinity increases because the radius decreases. As we mentioned, that when the radius decreases, more attraction. So it's easy to attract more electrons. So electron affinity increases. The atom will love to get more electrons. Okay? But from up the group, also the affinity to gain electrons will be more because the radius increases down the group. So the top of the group will have the smallest radius, the more attraction force, the more the atom will love to accept more electrons. Summary of the periodic trend. The arrow refers to the direction of increase of the trend. Down the group, atomic radius increase. And ionization energy decrease, electron affinity decreases too. Across the period, ionization energy increase, electron affinity increase, and atomic radius decreases. Okay? From left to right, atomic radius increases. Again, as atomic radius increase, as there is less attraction force, which means it's easy for the atom to lose an electron. Is less affinity to gain electron. When the radius decreases, attraction force increases, so it will be difficult to lose an electron. So ionization energy will increase. We'll need more energy to lose an electron. Electron affinity will increase because the atom will love to accept more electrons. Stop here for today. I don't want to extend the video more. Okay. Today, we explained, to wrap up what we said, we explained the periodic trends, the trend of certain properties over the periodic table. The chemical reactivity, the radius, atomic radius, the electron affinity, and ionization energy. Okay, this is a summary. This diagram is a summary of the trends of the periodic table. Thank you for watching and see you next video.